Thanks very much, Saeed, and thanks to QED-C for inviting me to take part in this webinar. I will start with the exciting news from our perspective that we were able to announce last week, which is that Covesion, based in Southampton in the UK, has joined forces with ADVR, who many of you may know, based in Bozeman, Montana, to combine our efforts in terms of technology development, product development across the nonlinear optical space. So we announced that last week. So what I've tried to do in the few slides I've got here is cover the activities, capabilities of both companies when it comes to quantum computing and sensing. Let me see if I can get that to progress. There we go. Right, so core technology. So both companies have a core competence in nonlinear frequency conversion and modulation based on a number of materials. These being periodically poled lithium niobate, magnesium doped lithium niobate, and KTP. And our history, if you like, is in the development of these materials in a bulk form, whether that's a bulk crystal or a bulk waveguide, to address many of the applications and challenges people have mentioned already. We've developed those materials into packaged, bulk component devices. So fiber coupling through integrated heater and temperature control. And across the two of us, we've got a sort of a component level solution range covering everything from free space chips through to fiber coupled components, bulk modules. And actually, one of the things that we've been doing at Covesion itself is looking at locked laser systems for quantum applications. But key to us is being able to access the full, transmission window of whatever material we're working with, whether that be lithium niobate or KTP. So looking at, generating frequencies, performing modulation right across the visible through to the mid-IR. The sort of applications that we already supply solutions into, I've kind of divided out a little bit. You can think of classical frequency conversion used in wavelength converting lasers. Adam just mentioned the inability to get a diode laser that works at every conceivable wavelength a quantum application might need. One of the ways you can then reach those wavelengths is through frequency conversion, through second harmonic generation, some frequency, difference frequency generation. So we've got a long history in working with laser manufacturers for the supply of these sorts of crystals. In the quantum arena, obviously quantum frequency conversion has become of great interest. Many of the quantum modalities, whether it's a quantum computing or quantum sensing modality, are based on requiring wavelengths around the visible, whether that's an ion, a trapped ion, a neutral atom, a nitrogen vacancy sensor. And then for networking applications, we need to shift those wavelengths without the loss of the quantum information to telecoms compatible wavelengths, which is eminently doable using nonlinear frequency conversion. ADVR in particular have a background in manufacturing phase and amplitude modulators based on lithium niobate, which again, key components for use in ion trapping and atom cooling. And then what hasn't been mentioned much so far is photon generation. So getting sources, whether that's pair sources or single photon sources, that work at the required wavelengths. So whether you're generating entangled photon pairs for QKD type applications, or whether you're looking for photon pairs of different wavelengths, so that one can be used in a quantum memory or in a telecoms fiber, versus one being used for free space comms, perhaps up to a satellite. Everything that we do, we've been in business. Covesion's been in business for 20 years. We are we're not bootstrapped. We reinvest our commercial revenue. So everything that we do has to have the ability to generate product sales and commercial revenue for us. So the market pull is absolutely critical. So what I've tried to show on this slide is the two directions that we see the market pulling us. Moving to the top, from bottom right to top left, there's a requirement for some applications to have higher power, higher optical power. So whether you're looking at an intermediate solution where you're addressing, a large qubit array and hence need high optical power, whether you're looking at rapid cycling of a rubidium atom interferometer for a accelerometer type application. So that pull drives you towards sort of the bulk end of a solution where you can handle higher optical power. You can efficiently couple that into fiber type components. In the opposite direction, obviously, you've got the desire for reduced swap, greater integration, more functionality at the chip level, and that pulls you down to photonic integrated circuits at the other corner of the slide. But between there are some intermediate technologies, based on different methods of manufacturing waveguides, be that in a bulk crystal, a thick film type solution, thin film, or full photonic integration. So the intention for Covesion and ADVR is to have a range of products spanning as much as possible these two almost competing market pools. So
sorry, Stuart, just a quick reminder, is over 7 minutes. If you could expedite, I would appreciate that to go for the questions.
Absolutely. So just to finish then and summarize where we are in terms of covering that span of market pool. We've got everything from bottom right, system level solutions, modules, and fiber coupled components, to up top left, where we're starting to work on waveguide based chip devices that have on chip functionality, whether that's filters, WDMs, integrating heterogeneous materials through a combination of KTP based wavelength converters and silicon PICs. So just to ensure that we can do frequency conversion modulation right from chip level through to component and system level. Again, as previous presenters have mentioned, more than happy to talk about collaboration, what we can do for you, what you can do for us. Here's some contact details to finish with, or feel free to contact me directly.